Hello and welcome to the sixth part of this demonstration of segment routing. In this video, we will explore adjacency segments a little bit more. In the previous video, we had used adjacency segments or adjacency labels to select one out of multiple outgoing ports for finer grained traffic engineering. In this video, we will use adjacency segments that are configured on more than one outgoing port. And so in principle, we'll be hashing over these more than one port when selecting this adjacency label. So that allows us, for example, in router 108 to hash over two outgoing ports that result in paths that are not ECMP paths. So we can actually load balance traffic over, for example, the 3-hop path to 106 as well as the 4-hop path to 106. So let's go ahead and configure a tunnel in the controller CLI. And we start with node 107 and define the adjacency which has been pre-configured on multiple outgoing ports. And then we get to node 108 and again use the other adjacency that has been pre-configured. And finally, we just give the final destination of the tunnel, which is 106. So that's all we really need to create these load balanced non-ECMP paths. So if we looked at switch 7 and its group table, we can see now that group 14 actually has two buckets, each which pushes the inner label 106. And each bucket of group 14 then group chains to two other groups that push the outer label, which is all 5/8. And so you can see that because the ECMP group has two buckets, it ends up choosing two of the possible 3 ports. But right now the traffic is still using all 3 ports in group ID 2 because as before we haven't applied the policy that takes this particular tunnel. So we can create a policy that will override the natural segment routing tendency to take the ECMP shortest paths. We will create this policy and give it the flow entry it needs to classify packets from the 10.204 subnet to the 10.202 subnet. We'll give it a priority, which, as we have seen before, can be used to choose between multiple policies. And then finally, we'll give it the tunnel that we just created, which load balances traffic over non-ECMP paths. And so, as before, we can see the tunnel, we can see the policy, and if we look deeper in the group table on switch 7, which is the head-end router, again, we can see that the packets are now taking this tunnel. Again, in the ACL table, that policy has been implemented as a group that we need to take, and group 14. And now we can look at the next router, which is router 108, and look at its MPLS table, because this router will be getting the outermost label as the all 8s, which is definitely not the bottommost stack label. And we can see that it says that the packet needs to go out of group 8 at this router. So if you look at group 8, it'll have the 2 buckets that we expect out of ports 2 and 3. And you can see from the destination max that we are setting in each of these, one of them goes to switch 2 and the other goes to switch 5 or router 5. And of course, as we watch the group, we can see that packets are getting load balanced over these non-ECMP paths.